This next example, example 4, is looking at a constraint optimization problem again. So what we know is that a company is under contract to deliver 77 units of two products, X and Y. It can be in any combination. All we know is that we either have to have 77 units of good X, 77 units of good Y, or at least 77 units of a combination of the two. And our goal here is we want to find that combination that minimizes the cost of fulfilling the contract. So how would we write our optimization problem? Well, to think about our optimization problem, we should think about this as we want to minimize our costs such that X plus Y, let's go to our symbols, maybe we don't have that. We're looking for greater than or equal to. So I thought it was up at top. Looks like I might be on a wild goose chase. It's going to be here somewhere. Here we go. Such that X plus Y is greater or equal to 77. Because that's our constraint. So now that we've written this out, all we need to do is insert this into Solver, and it'll go quite quickly as to what we need to do. So let's set up here our X and our Y. And now we have our cost function, which is equal to 7 times X squared minus 2 times X times Y plus 5 times Y squared plus 64. So that's our cost function. We now have our left-hand side constraint and our right-hand side constraint. Our left-hand side constraint is equal to X plus Y. Our right-hand side constraint is 77. So by writing it out, it should be fairly easy to see exactly how these things come into play. So we have our cost function, which we want to minimize, with our left-hand side and our right-hand side constraint. So all we need to do now is go to Solver, and we want to minimize our cost by changing X and Y. We want to do so such that we produce at least greater or equal to 77 units of good X and Y. We click Solve, and so therefore this tells us we should produce 33 units of good X, 44 units of good Y. We satisfy the constraint, and our total costs are $14,463.